Okay, this is going to be a little overview of some simple molar conversions, just one-step conversions that you've been working on in your homework, just to make sure that we're okay, we're all there. Then the second part of the video is going to be introducing you to two-step conversions that are molar conversions, and how to show those with factor label and all of that. So one quick thing I wanted to do is, if you haven't already written on a periodic table somewhere, I think that it's pretty important that you write on one of these so that you can remember what goes where, what values we're using to make all these conversions. So I'm just going to go through that really quickly one more time. So Avogadro's number right here, you probably have this memorized: 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. Now, this number is huge, and it doesn't make sense with anything unless that thing is very, very tiny. So that thing is particles, and that I'm going to just put PC for particles. Okay, so 6.02 times 10 to the 23rd particles equals 1 mole of a substance. Okay, 6.02 times 10 to the 23rd particles equals 1 mole of a substance. Now, we don't ever really use particles when we're doing calculations because there are different kinds of particles, and we're using a very specific kind depending on the substance. So this right here, particles, can either be atoms, which, remember, we abbreviate atoms as AT. It can be molecules if we're talking about a covalent substance, and we abbreviate molecules MC. Or, I'm going to write it up at the top, it can be formula units if we're talking about an ionic compound, and formula units are abbreviated FU. Okay, so those are the three choices that we're really going to be working with right here instead of PC. Okay, but 6.02 times 10 to the 23rd things equals 1 mole of a substance. Okay, molar volume. First of all, remember STP. STP means standard temperature and pressure. So this is only at 0 degrees Celsius. That's our standard temperature. And standard pressure is 1 atmosphere, or 101.3 kilopascals. We haven't worked with this very much yet, but this is the pressure at sea level. Okay, so at sea level, when it's 0 degrees Celsius, there's something called molar volume. This also is only for gases. This is only for gases, okay? Volume at STP, we will only use that for gases. Okay, but here's what molar volume is. It's 1 mole equals 22.4 liters. It does not matter what kind of gas you have, whether it's helium, carbon dioxide, oxygen, carbon monoxide. It doesn't matter. Any gas at STP, so sea level, 0 degrees Celsius, will have a volume of 22.4 liters per mole, period, end of sentence. All gases have that volume for 1 mole at STP. Okay, so that is what we will use there. Okay, then we have molar mass. We are going to be using molar mass. Remember, 1 mole is where this word molar comes from. Okay, so molar volume is the volume of 1 mole. Molar mass is the mass of 1 mole. Okay, so 1 mole has a certain number of grams. Okay, and I left that number blank. Now, why did I do that? Well, that's because every substance has a different molar mass. 1 mole is always this number of particles. 1 mole of a gas will always be this volume at STP. Okay, but 1 mole of a substance has a unique molar mass. It depends on what the substance is made of. And we have to add that number up from the periodic table. Add it from the periodic table. So if I'm just talking about 1 mole of argon, well, argon's a noble gas right here. I just look at the periodic table and I see 39.9 right there. That means that 1 mole of argon equals 39.9 grams of argon. But if I'm talking about 1 mole of carbon dioxide, well, carbon dioxide is CO2. Well, we need carbon and 2 oxygens all added together. So 12 plus 16 plus 16, and we get 44.0 grams is 1 mole of carbon dioxide. So 44.0 would go right there. Okay. All right. So that, again, hopefully is something that you've seen before. We definitely need to know all of this information so that we can use it on these calculations. So what I want you guys to do right now, I'm going to zoom out here by raising my camera. Let me autofocus that. Okay. Pause the video, try these 3 problems, and then go ahead and push play, and I will go through them really quickly just to make sure that you are doing these right before we make it more complicated. So pause the video now. Okay, first question, how many molecules are in 17.3 moles of CH4? Well, if we look at our molar map here, okay, we are being given in this problem, we're being given moles of CH4, right? Moles is where we're starting. It's asking for molecules of CH4. Molecules are one of our particle types. So we're trying to go from moles to molecules, which means that all we need is Avogadro's number, and this is our conversion factor, okay? So we're starting with what we're given in the problem, 17.3 moles of CH4. My conversion factor is Avogadro's number. 1 mole equals this many, in this case, molecules, because we're talking about a covalent compound, of CH4, okay? 1 mole has 6.02 times 10 to the 23rd molecules. Well, where do I want to put 1 mole? Always ask yourself that. Where do I want to put 1 mole? It's based off of what we want to cancel. Well, I have moles right here. I want to cancel moles, so I want to put 1 mole on the bottom. 1 mole of CH4 has 6.02 times 10 to the 23rd molecules of CH4. Sorry, my handwriting got a little sloppy there. I'm trying not to smear since I'm a lefty. All right, moles cancel out, multiply, and we're done. Okay, that is the whole problem. So when we do that, we're going to end up with 1.04 times 10 to the 25th molecules of CH4. 1.04 times 10 to the 25th molecules of CH4 is your answer. If you're not getting that in your calculator, see me, email me. Let's figure out how to use our calculators, okay? All right, next one, 31.9 grams of water is how many moles, okay? Again, look at this molar map. It tells you exactly what to do. We are given grams. Grams is mass. We are asking for how many moles. Moles is moles, okay? If I'm going from mass to moles, the only conversion factor I need is right here. 1 mole equals a certain number of grams, which comes from the periodic table, okay? So for this problem, I need to know what that molar mass is. So I look at the front of my periodic table. I find hydrogen weighs 1.0. Oxygen weighs 16.0. So now I'm going to add up what water weighs. 2 hydrogens would be 2.0. 1 oxygen, 16.0. 18.0 grams is 1 mole of water. Okay, so 18.0 grams per mole. I'm going to need that. Okay, start with what you're given in the problem. Always start with what you're given in the problem. 31.9 grams of water. Where do you want to put 1 mole? Always ask yourself that. Well, I don't want to cancel moles because this isn't moles. I want to get to moles. So 1 mole goes on the top. 1 mole of H2O weighs a certain number of grams, which I just figured out over here. 18.0 grams of H2O is 1 mole of H2O. So cancel those out. Now I'm dividing by 18. My answer should have 3 sig figs because that is my lowest number of sig figs in the problem. And I'm going to get 1.77 moles H2O. Okay. All right. Third one. How many liters are in 0.35 moles of helium at STP? Well, liters. Yeah, I didn't write that on here. I didn't write grams on here either. Remember, if you don't know this already, please write this, okay? Mass is grams. This is grams. Okay, volume is liters. So this is liters. So if it's asking you how many liters, that means we're trying to get to volume. How many liters are in 0.35 moles of helium at STP? Well, we're trying to get here. We're starting in moles. So all we need is this right here. 1 mole equals 22.4 liters. Okay, so start your problem with what you were given. Okay, 0.35 moles of helium. Remember, this at STP is just telling us that we're at 0 degrees Celsius and sea level pressure. It's important because there's another volume over here, which we will learn how to get to later. But for now, if we ask you for volume, it's always this that we're going to, volume at STP. Okay, back to the problem. 0.35 moles, that's our starting point. 1 mole equals 22.4 liters. Where do I want to put 1 mole? Well, 1 mole needs to cancel the moles of helium. So 1 mole of helium has a volume of 22.4 liters of helium. Okay, so moles cancel out, multiply across, and I'm going to end up with something that only gets 2 sig figs because 0.35 only has 2 sig figs. So answer for this one, 7.8 liters of helium, 7.8 liters of helium. So hopefully you did those 3 right, and we're ready to make it more challenging. All right. 2-step molar conversions. So now instead of just 1 conversion, all of these are going to have 2. Okay, I'm going to do 2 examples, and then you're going to be ready to go with the problems that you have in the assignment page. First one, 3.48 grams of CO2 is how many liters of CO2 at STP? Well, here we go. Remember, grams is here, mass. I am trying to get to liters, which is volume at STP. I can't go straight there. These are not connected. I have to go to moles first and then go to volume. Okay, so follow this chart. It tells you the steps that you need in order to solve every problem. Okay, so here we go. Start with what we're given, 3.48 grams CO2. And then let's look at our little molar map to figure out what our first step is. Well, if I'm starting in grams, it doesn't matter where I'm going. I have to use molar mass to get away from mass, right? So this is my first step. 1 mole equals a certain number of grams, which comes from the periodic table. So let's add up carbon dioxide from the periodic table. Well, carbon has a mass of 12.0, oxygen 16.0. 1 carbon is 12.0, okay? 2 oxygens, 16.0 times 2, 32.0. Add those 2 together, 44.0 grams. Remember, when you're adding those numbers on the periodic table, you're always getting grams, okay? That's the number of grams in 1 mole, okay? So where am I going to put 1 mole? Always ask yourself that. Where does 1 mole go? Well, I'm not trying to cancel moles yet. So I need 1 mole on the top, 1 mole of CO2, and I just added up is 44.0 grams. And I want to cancel grams, so grams go on the bottom. 44.0 grams of CO2. 44.0 grams of CO2 is 1 mole of CO2. So grams cancel out. Now what? Again, trying to get to liters. So I've gotten to moles. I just used molar mass. I'm in moles because that's the only thing that hasn't canceled is moles. Trying to get to liters. Whoop, molar mass. 1 mole is 22.4 liters. Where do I want to put 1 mole? Okay, always ask yourself that. 1 mole goes on the bottom. Okay, this time on the top, we're getting to liters. That's our molar volume, 22.4 liters CO2. Cancel those out. We're going to divide by 44. We're going to multiply by 22.4. Everything has 3 sig figs. So this will end up being 1.77 liters of CO2. 1.77 liters of CO2. All right. Next one, 4.97 times 10 to the 23rd atoms of helium is how many liters of helium at STP? Okay, here we go. Atoms. Where are atoms of helium? Atoms are a type of particle. They're up here. So this is where I'm starting, particles. I'm trying to get to liters of helium at STP. So I'm trying to get to volume at STP. Straight shot all the way down. First step is Avogadro's number. Second step is molar volume. Just remember all of these things, every single one of them is equal to 1 mole, and that will help you figure out where to put things to cancel. So start with what we're given, 4.97 times 10 to the 23rd atoms of helium. Set up your factor label grid, or if you prefer to do a multiplication sign with fractions, multiplication sign fraction, that's fine. Same thing, okay? First step to get away from particles is going to be Avogadro's number, 6.02 times 10 to the 23rd atoms, because we're working with an element, a monatomic element nonetheless, equals 1 mole, okay? So where do I want to put 1 mole? Where does 1 mole go? I don't want it on the bottom because that won't cancel atoms. I want 1 mole on the top, Avogadro's number of atoms on the bottom, okay? So 1 mole helium would have 6.02 times 10 to the 23rd atoms of helium. Atoms go away. Almost there. Trying to get to liters. We've gotten to moles. Now we're going to liters. 1 mole is 22.4 liters. So where do I want to put 1 mole? Hopefully you're saying put it on the bottom to cancel. 1 mole of helium would have a volume of 22.4 liters at STP. So 22.4 liters of helium is the same as 1 mole of helium at STP. Moles cancel out. Everything has 3 sig figs. Divide, multiply, get an answer. This one is 18.5 liters of helium. If you have not punched one of these problems into your calculator, this is the one you need to punch into your calculator to see if you're using your calculator correctly. If you are not using your calculator correctly, you're going to end up with 1.85 times 10 to the 45th or 6th or something like that. Not the right answer. You need to end up with 18.5. If you're not ending up with 18.5, email your teacher, tell her what kind of calculator you have, and she will tell you how to use it. If you don't learn how to use your calculator now, you are not going to like your test scores in the next few chapters, okay? Figure it out. Let's figure it out, okay? If you have any other questions, also please reach out, but that is the little tutorial on 2-step molar conversions. Now it's your time to practice. Please go to the assignment page and get those practice problems completed. Thanks for tuning in, and we will see you in class.